Today we're going to talk about volcanoes. This is an example of a volcano here. As you can see, the molten material spewing out slowly. Alright, so what is a volcano? A volcano is any place where gas, ash, or melted rock can come out of the ground. It technically does not have to be a giant mountain, believe it or not. Many volcanoes are dormant or not currently erupting, and often form as rock below the surface. So dormant is something we want to know about, and that basically means sleeping, okay? So it's going to form as rock below the surface that basically melts and rises to the surface because it's magma. Once it erupts, it becomes lava. So lava equals outside. It has to be on the surface to be lava. So lava and ash erupt from the volcano's vent, which is the top part, and then it will cool and harden into new rock, specifically igneous rock. All right, so here are the parts of a volcano. This hole right here is the crater. Any opening on the side is known as a vent. The magma chambers down here at the base. The part that leads up is the pipe. The actual shape of the volcano is the cone. Anything that's flowing on the surface is a lava flow. And the most dangerous part is the pyroclastic flow or ash cloud. All right, so how do volcanoes form? Well, there are two types of things you need to know about when we talk about how volcanoes form. Viscosity, and that can be low or high. So volcanoes form from lava being ejected from the mountain building up around a vent and creating the actual mountain shape itself. As the volcano erupts and explodes, it builds on itself, especially if it's the kind that flows lava, like here. So viscosity is the resistance to flow. This is very important. Everything that's a liquid has viscosity, including things like water, syrup, including things like sweet tea, even something that would be thick and oozy, kind of like molasses. All of those still have a viscosity. Mustard, ketchup, any type of sort of liquid material. So low viscosity lava flows easily. It's in non-explosive eruptions, okay? Gently sloping sides. So this is going to be a non-explosive eruption right here. So this is going to be low viscosity, meaning it's just going to flow quickly. In terms of low viscosity, things that flow quick, in terms of liquids, would be like water. Water has a pretty low viscosity. High viscosity lava does not flow easily, and it's from explosive eruptions with steep sloping sides. So high might be something like molasses. Okay, this is the pyroclastic flow. This is the lava flow. All right, so there are three types of volcanoes. We have shield, we have cinder cone, and we have composite. Let's start with shield. Shield volcanoes are non-explosive volcanoes, which means they erupt lava, okay? So lava flows out of the vent and hardens on top of the previous layers. So basically what happens is right here, every time the lava flows, you're going to have a buildup. That's how the volcano continues to grow, because it's creating more igneous rock. Okay, it has a wide base, noting it's very wide here on the bottom, and gently sloping sides. Kind of looks like a shield. That's where it gets its name. Best example, the Hawaiian Islands. The second type of volcano is a cinder cone volcano. And cinder cone volcanoes are explosive eruptions, okay? Pyroclastic flows explode out of the volcano because it has thick magma. It's also very steep-sided. If you look right here, you'll notice it literally looks like a cone. That's how it gets its name. So this is explosive eruptions with pyroclastic flows. Oftentimes they are going to be the smallest in size. The third type of volcano is a composite volcano. It is also known as a stratovolcano, so it has two names. This type of volcano has alternate explosive and non-explosive eruptions, meaning it can erupt both pyroclastic material and lava. So the actual volcano itself is made up of alternating lava flows as well as ash, cinders, and bombs that have all exploded and continued to pile up. It is very large. It is very steep-sided. It is also called a stratovolcano. And its great example is Mount St. Helens. Another good example is Mount Fuji, which is found in Japan. Mount St. Helens is in Washington State. All right, so some other volcanic landforms that are created are fissures, lava plateaus, craters, and calderas. A fissure is a lava flow from giant cracks in the surface. This is a fissure. This happened about a couple years ago in Hawaii, and lots of parts of the Hawaiian Islands were opening up, creating new fissures that had never been there before, causing major structural damage to a lot of the homes and the landforms that were in the area. A lava plateau is a flattened layer of cooled lava. A crater is the opening at the top of a volcano, so like this part right here. And then a caldera is when the crater collapses into the magma chamber, and oftentimes this leads to a lake. Such as Crater Lake. All right, so where do volcanoes form? At divergent boundaries, convergent boundaries, and at hotspots. So at a divergent boundary, most form at mid-ocean ridges as the two plates pull apart. So we already have learned that rift valleys are right here in the middle of the mid-ocean ridge. And basically what happens is the plates are moving in opposite directions. When that happens, the new magma is going to rise up, creating the volcano itself. This also causes many fissure eruptions. A great example is Iceland, because Iceland, the entire country, is literally divided like this, and the two parts of the country are moving in opposite directions. They have lots of fissure volcanoes. Second type of place that they occur is a convergent boundary, and this is where volcanoes form when oceanic crust returns to the mantle to form trenches, where subduction happens. Okay, so magma has high water content that creates very strong composite volcanoes and often explosive eruptions. So basically two places this is going to happen. At oceanic collisions, which is at a convergent again, you're going to get an island arc, which is a string of volcanoes out in the water. Or at ocean continental collisions, you'll get a set of continental ranges such as the Ring of Fire and the Cascade Range, which is what you have here, where Mount Rainier, Mount Adams, Mount Hood, the Three Sisters, Crater Lake, and Mount St. Helens are all located between Washington and Oregon. This is the Cascade Range. All right, so this is the way that the continental oceanic and oceanic collisions occur. As you can see in the pictures, if you watch the arrows, they are moving. And it shows how the lava starts to heat up. What you're seeing on this side right here represents what's in this picture over here. You have your subduction occurring, forcing the melted magma to rise up, creating the volcano on the surface at an oceanic continental. For oceanic, you have your subduction creating that trench that causes the melting to happen and the rise up of the magma, creating this island arc. As you can see here, it forces the magma up, creating the volcano. And here you can see what's going to happen in oceanic. The magma starts to pool, gets heated up, eventually will warm up, get very hot, rise up, and form your island arc. And there's your volcano. All right, hotspots are weaknesses in the Earth's crust where a magma plume basically allows magma to rise up to the surface. So this might be your magma plume. Notice in the asthenosphere there is nothing here. And then there's this hot spot of magma that's underneath the plate inside the asthenosphere. When it rises up, it's going to create basically an island or a string of volcanoes. So the string of volcanic islands will be over what's considered to be the hotspot. We know that it's over this area because there are lots of Hawaiian islands. If you look at these, it lists them all. You have what started here as seamounts moving all the way. The Pacific plate is moving this way. So it shows you the difference in how long they've been there. And of course, new ones could form here at any point in the future. A couple of great example volcanoes that are hotspots are Kilauea in Hawaii, very active volcano, and the Yellowstone supervolcano, which last erupted 75,000 years ago. These are where most of the active volcanoes are. Note this right here is the Ring of Fire, lots of active volcanoes there. This right here is subduction. This is the East African Rift Valley, and all of the Ring of Fire subduction as well. Not all of it, but most of it anyway, that's highlighted.